Our topic name is Solar Power Generation System for Home Application using Matlab Simulink. Our group members are Sonone Tejas, Thorat Kalyani, Sirsagar Sudarshan, Roham Sushti and Paigode Chaitanya. So the introduction. Solar energy is a vital resource that sustains life on Earth and offers an inexhaustible supply of clean energy. The utilization of solar cells in various industries and household appliances is on rise due to anticipated significant role of solar energy in future smart distributed renewable sources. The amount of sunlight energy that reaches the earth every hour is ample enough to meet the world's annual energy demand. In today's generation, the need of electricity persists on an hourly basis. This review presents a comprehensive electrical model for 5.8 kilowatt solar photovoltaic grid-connected power system. The aim is to effectively track the maximum power points considering the fluctuation in solar irradiation and temperature. Additionally, the project focuses on providing an analytical evaluation of the challenges associated with advanced grid-connected inverter system. To validate the proposed 5.8 kilowatt solar PV grid-connected power system, a modulation and simulation are conducted using Matlab Simulink.
So our simulation topic is solar power generation for home appliances. So in that, first we can add all the components on the window that we have to require to develop a circuit. So first of all, we can add PV array. Then we will add two constants. Then next we will add the scope, which can give the waveform. Then another one will be RLC branch. Then we will add diode. Next, we will add IGBT. Next, pulse generator. And to measure the voltage, we can add voltmeter. Then universal bridge. And last, we have to add PWM generator, that means pulse width generator.
The components which we have taken on the screen, let's make the circuit from this. For making the circuits, we have taken the components as shown in previous video. So the constants is added first. So the value of constant is changed as 1525. Then we have added two RLC branch. So the we will change the RLC branch into inductance and capacitance. So first let's take the inductance. So the value of inductance will be 0.06 and the value of conductance will be 0.07. We add these so as capacitance is used to store the capacity of the circuit, and then we will join the IGBT to the inductances and capacitance. Then we will add the diode to the circuit. So these all components are needed to join to make the circuit.
Now by taking series RLC branch, by selecting capacitor and connected it along with diode and IGBT, which completes the boost converter, here value of capacitor is set to 0.06 farad. Positive terminal of capacitor is connected to diode and negative terminal of capacitor is connected to the IGBT. Universal bridge is taken as inverter. Here input is DC given in terms of positive and negative terminal, and output is AC. We taken single phase, so number of arms is selected as 2. Unselected device is diode. Universal bridge is connected to capacitor by connecting its positive and negative terminal. Key components of universal bridge are 4 actively controlled switches, diodes for rectification and filter. PWM generator having second level is connected and selected at its modulation index to 0.8. Also, single phase full controller with 4 pulse is selected. After that, again series RLC branch is taken, and here we selected resistance to connect it along with universal bridge, which is our inverter. Here upper terminal is connected to A terminal.
Add a voltmeter to measure the voltage across the load resistance, and to display the voltage waveform we have to add a scope in front of voltmeter. Then we also have to measure the voltage across the capacitance branch. So we going to add one another voltmeter against the capacitance branch, and same to display the voltage waveform we have to add a scope. Just we have connect the voltmeter terminals to the both terminals against the capacitance branch, and then we are going to provide an impulse or pulse generator to the yes, and we just have to provide the pulse, and again we have to measure the voltage across voltage generated by the solar panel. So we are going to connect one another voltmeter again across the input means output of solar panel, and scope to display the voltage, and we have to change the parameters of the solar panel. And we are going to provide a source that going to provide a power for our circuit.
The project model is a 5.8 kV connected solar PV system is a Matlab simulating including the components like a solar PV average in the PD controller from the power regulation DC boost controller will increase the output the from DC to AC conversion in the end of LC filter is the reduce the current harmonic the successful simulation in the system offers foundation in the future research and improving the performance under the raising the weather condition, the increasing the energy, storing the gulls, exporting the advantage controls, storing the testing real world advantage with technology and smart gulls integration would also lead to more efficiency in the setup.